Okay, let's get right into it. Today, we're going to uncover the surprising truth behind this idea of AI's massive thirst and what its real impact is on our planet. You've seen the headlines, right? Maybe you've even felt a little guilty asking an AI a question. But what's the real story here? Is your next search query actually going to drain a reservoir?
Well, here's the thing. When you zoom all the way out and look at the entire planet's water budget, AI and data centers, they're barely a rounding error. I mean, to put it in perspective, agriculture is the undisputed giant, using a staggering 70% of all freshwater. Now let's zoom in on some of the big names. You might be surprised to see that the Coca-Cola system uses more than 10 times the water Google does for all its operations, including AI. And get this. TSMC, the company that actually makes the chips that power AI, uses 3 to 4 times more water just in manufacturing. This is where it gets really relatable. The water it takes to make a single pair of jeans, that could power hundreds of thousands of AI queries. And that hamburger you might have had for lunch, its water footprint is equivalent to about 100,000 questions for your favorite AI. So this is the big question, isn't it? If AI is just a drop in the global bucket, why is it making such a huge splash in the news? Because, as it turns out, it's not about how much water is used. It's about how and, crucially, where. And this is where the story gets really complicated. We have to look past that big global pie chart and start focusing on the local hotspots. Okay, here's the absolute key difference: withdrawal versus consumption. So a power plant might pull in huge amounts of water, but it returns most of it right back to the river. AI data centers, though, often use what's called evaporative cooling. They consume the water. They turn it into steam that is lost from that local watershed forever. And this consumption is what's leading to these major flashpoints. In places that are already drought-stricken, like Uruguay, Arizona, and Spain, you've got tech giants building these thirsty facilities, and that puts them in direct competition for scarce water with local citizens and farmers. This was the actual rallying cry in Uruguay during its worst drought in 74 years, a time when the top water in the capital was literally being mixed with seawater just to have enough. So you can imagine, the idea of a new Google data center consuming millions of liters a day felt less like progress and more like plunder. So all this public pressure is forcing these companies into a really difficult environmental trade-off. I mean, they can't just ignore the protests, but the alternative to using water, well, it comes with its own serious consequences. The main alternative to water cooling is called dry cooling, and the easiest way to picture it is it's kind of like the radiator in your car. Instead of using evaporating water, it uses giant fans to blow air over hot pipes. It works, sure, but it's like trying to cool an engine on a hot day with no coolant. It's just not very efficient. This slide lays out the core dilemma perfectly. If a company switches to air cooling, its water usage drops to zero. Great. But its electricity bill skyrockets. And if that extra electricity comes from fossil fuels, its carbon footprint gets bigger. It's a crazy environmental irony. Saving water can end up polluting the air. So it feels like an impossible choice, right? But what if there's a third option? A technology that looks like something straight out of science fiction that could solve both the water and the energy problem at the same time. The solution is called immersion cooling, and it relies on this kind of magic liquid called a dielectric fluid. Seriously, imagine a liquid you can literally submerge a running computer in without it shorting out. It doesn't conduct electricity, but it's absolutely fantastic at absorbing heat. The most efficient version of this is it's incredible. The AI chips get so hot, they literally boil the fluid right on their surface. The vapor rises, it cools, and then it rains back down. It creates this perfect, self-contained cooling cycle that uses zero water and far, far less energy. So if it's so great, why isn't every data center a giant boiling tub of servers? Well, the reality is, it's messy. You need a crane just to service a server. The tanks are incredibly heavy. And you can't just pour this stuff into an existing facility. It usually means building from the ground up. But for those new facilities, there is one final, absolutely brilliant advantage. Because this liquid system captures nearly 100% of the computer's waste heat, you can actually do something really useful with it. Think about it for a second. Almost all of the electricity that goes into a computer chip comes out as pure heat.
It's not moving anything, it's just flipping billions of switches. So, for all intents and purposes, it is a tiny digital furnace.
For decades, we've spent billions of dollars on getting rid of that heat, just blowing it away into the atmosphere as waste. But what if we started treating it as a resource instead of a problem? You could use that waste heat for something as simple and wonderful as heating a community swimming pool. And this isn't just some clever idea, it is happening right now. In the UK, a company called Deep Green is already using a small data center to provide free heat for a public pool. In Finland, a new Microsoft data center is going to provide district heating for 250,000 people, allowing a coal plant to be shut down. This is not science fiction. This is the future. We are at a clear turning point. We can keep building data centers that stress local water supplies, or we can build smarter facilities that use no water, saves energy, and plug directly into communities as a source of clean heat. The problem of AI's thirst could actually become its greatest contribution to a sustainable future.